Yes, hello Naushad, welcome on YourPedia platform, and let's start your IC engine snap for your final JKPSC interview for the
Yes,
post
sir.
of assistant engineer.
Yes, sir.
So,
Thank you.
because now, sorry, Naushad, tell me how combustion takes place in SI engine.
Sir, the combustion takes place in the SI engine with the help of the spark plug. Sir, what happens is that in the carburetor, we get a homogeneous mixture of the air and the fuel. We mix that in the carburetor, and then that is injected via the intake manifold to the combustion chamber. And with the help of the spark plug, we initiate the spark in the combustion chamber, and then the flame front propagates across the combustion chamber, and there is also Sir Ricardo also defined the different stages of combustion that we study in the under the normal and abnormal combustion cases. Yes, sir.
Okay. Naushad, can you tell me, can you show different stages of combustion in IC engine on P theta diagram, pressure versus crank angle diagram?
Yes, sir. Ideally, or sir, you want, sir, some actual representation, sir. Sir, because yes, sir.
Show both.
Okay, sir. Okay, sir.
Okay.
I am drawing, sir. So this is my compression. This is heat addition. Sir,
Hello?
in ideal case, sir, it will be like something like. Yes, sir. Sir, in ideal case, the pressure rise will be exactly, sir. We are adding the heat at constant volume, so it will exactly lie along with the TDC. But in ideal case, my pressure rise will be after the top dead center.
So show the different stages of combustion.
Oh, okay, sir. Okay, sir.
And which one will be the motoring curve? You have not shown the motoring curve.
Yes,
what is that?
Yes, sir. Yes, sir. Yes, sir. I will show the motoring curve also. Sir, this is the first stage of combustion. This is the second stage, and sir, there is the motoring curve like this. This is the second stage, and this is third stage. Sir, these are the three different stages. Sir, the first stage and the second stage, when the second stage starts, we say the motoring curve. As we see the pressure rise, when we see the considerable pressure rise, from that point we call that a motoring curve, and because we stop, sir.
This stage one is having some specific name.
Sir, it is called, yes, sir. Stage one is called ignition lag, sir.
Ignition lag.
Yes, sir.
Okay. So where that stage one is going to end?
First stage going to end where we see the considerable pressure rise, sir, which means that the our mixture of air and fuel has reached a stage where we can see the flame front has, sir, our nuclei has developed so that it will now propagate across the combustion chamber. Otherwise, beyond that, there are chemical reactions that are helping to develop the flame. We can say the flame front.
Okay. Naushad, in SI engine, the abnormal combustion takes place in the start of the combustion process or at the end of the combustion process?
Sir, that sir, in SI engine, it is at the end of the combustion process, sir.
End of the combustion.
Yes, sir.
So how we can avoid this abnormal combustion in SI engine?
Sir, there are various parameters that we have come to know after the experiments. We generally, from the design perspective, what we do is, sir, we try to make the engine cylinder small, and we try to make the surface area to volume ratio, sir, make that high, and we try to induce the turbulence. Another thing is, sir, we actually what we try to do is we try that the maximum pressure that is that reaches during the combustion, that should not be at the top dead center, so that the engine can, at that point, the engine will feel most of the vibration. We try to avoid that. We take the maximum, we try to sir, we try to reach the maximum pressure after the piston has crossed the top dead center, in order to avoid the, sir, the vibrations in the engine.
Mhm. Okay. What is equivalence ratio, Naushad?
Sir, the equivalence ratio is a ratio of the actual air fuel ratio to the stoichiometric air fuel ratio, sir.
Are you sure it is air fuel ratio or fuel air ratio?
Fuel air ratio, sir.
Fuel air ratio.
But I'm not really sure. But why I don't? It is, sir. I think it is. I'm not sure, sir. It is air fuel ratio or fuel air ratio.
So how much equivalence ratio is required for maximum power?
Maximum power for that, we go for more than one.
More than one.
Yes, sir.
Vishal, how much air is required for the complete combustion of 1 kg methane?
1 kg methane, sir. I think it is for. I think I am not sure, sir. But I think it's 12. I have studied somewhere, but sir, I'm not sure about it.
So can you give me some idea from where you can calculate that?
Yes, sir. We try to balance the, for example, the chemical formula of the methane is CH4, and by balancing the equation with the O2, we do generally make the equation CH4 plus O2, and the resultant are CO2 and H2O generally we consider, and then we try to balance, and sir, we get the weight of the air, or we can say the volume of the air required for the complete combustions.
Okay.
Yes,
Vishal, what are the main differences between the fuel air cycle and air standard cycle?
Sir, the air standard cycle and fuel air cycle is, sir, what in air standard cycle we have the different assumptions that we do not consider in the fuel air. Fuel air cycle is actually, sir, we actually study what is happening with the fuel during the entire cycle. In air standard cycle, we generally do not consider the fuel. We take the air. We take the air into consideration without considering there is the also in the combustion there is also the fuel present in it. So we say because the fuel there are various changes when the combustion is happening. There is dissociation, the specific heat changes with the temperature in the combustion, but in air standard cycles we do not consider. We take that the specific heat is constant as the system there is only air present. Those are the assumptions, sir, in case of the air standard cycles.
Okay.
Yes, sir.
Acha, carburetor nowadays replaced in petrol engine.
Yes, sir. Yes.
Using some direct injection system.
Yes, sir.
Can you tell me what are the advantages we get by using a direct injection system?
Exactly, sir. Yes, sir. Actually, what was happening is that in the SI engines, the main motive was that we should be able to mix the air and the fuel as accurately as possible, so that there should be the maximum limit to get the homogeneity in the carburetor. What was happening is that we are not able to, sir, get the homogeneous mixture. We can say the ideal homogeneous mixture, but in order to overcome those things, we used the injection systems. In injection systems, what we did is that we injected the fuel very near to the inlet valve of the cylinder. By that, what happened is that we were able to mix the air and fuel more homogeneously, and the advantage that we got is that we saw the reductions in the emissions, and the combustion was happening, combustion was occurring very smoothly, and we were able to get better fuel economy. We can say the conditions were meeting. We were able to meet very, sir, the stringent norms that the government has applied for the we were able to meet the stringent emission norms, we can say, sir. Yes, sir.
Okay. So what kind of pollution we generally observe in case of petrol engine? How the pollution from petrol engine is different from pollution from diesel engine?
Sir, in petrol engine, there are generally, sir, we can say there are hydrocarbon losses. There is the pollutants are the carbon dioxide, carbon monoxide, and oxides of the nitrogen. And in the diesel engine, we see a lot of more than those, like the hydrocarbons and oxides of carbon or nitrogen. We see also the particulate matter. In that, we see the oxides of sulfur, we see the soot, no, I don't know soot, but sir, particulate matter, and I think the oxides of sulfur, those are extra in this diesel engine, sir, apart from.
Okay. Navshad, you drive any vehicle?
Yes, sir.
Which one?
Alto 800, sir.
Alto 800. What is that 800 means?
Sir, that is the capacity of the engine, sir, in terms of the volume, sir.
800 means what?
800 means 800 cubic centimeters of capacity. You know, sir, if for example, if a car has, you know, sir, a four cylinder, if there is 4-cylinder engine, and each cylinder has the cubic capacity of volume of 200 centimeter cube, so the total capacity will be multiplied by 4, and that we call it that is equal to the 800 cubic centimeter.
That is a 3-cylinder. Alto 800 is having 3 cylinders, 4 cylinders, or more than that?
I think 4 cylinders, but sir, I'm not really. I think I saw it on the, you know, sir, registration certificate. It is 4-cylinder. Yes, sir.
Fine. So, what are the main components there in, you know, powered steering?
Powered steering, in power steering, apart from the conventional steering, we have hydraulic pump in that, which assists us in the rotation of the steering, or we can say the driving. And there is the pump. We have the master cylinder. And we have I don't know exactly what we have apart from that.
Okay. Nishant, how ABS system works? You heard about anti-lock braking system?
Yes, sir. Yes,
how
sir.
It
Yes,
works?
Sir, what happens is that we attach a ring on this wheel. The ring, there are grooves on the ring. What happens is that when there is, but sir, you know, sir, I will explain, but I am not really sure about it, but I will try to explain, sir. Okay, sir?
Okay, go ahead.
Sir, what happens is that there are the grooves on that ring. What happens is that when the wheel is rotating, when we apply the brakes, as the brake shoes are held against the disc, there is on the ring, what happens due to the grooves is that there is the disruption in the magnetic field. And that magnetic field is, you know, processed by the ECU, and we get the ECU gets to know the rotation, or whether the wheel is rotating or the wheel is just, you know, that is skidding. And by that, the ECU processes and it releases the brakes and applies the brakes, release and applies, so that our wheel does not get locked, and we are able to, you know, sir, the braking distance is reduced.
I think now I can give you the feedback.
Yes, sir.
Nishant, IC engine question, you know, most of the question you are answering correctly.
Okay,
I started with the IC engine combustion process. What are the different stages of combustion? How combustion initiate in SI engine? Abnormal combustion, how we can avoid it?
Yes,
तो वो सब चीजें आपने correctly answer की. Equivalence ratio is the ratio of the actual fuel air ratio to the stoichiometric fuel air ratio. It's ratio of fuel air, not air fuel.
Okay, sir.
मीथेन के लिए थोड़ा चेक करना आप, मेरे ख्याल से ये 17 point something आता है.
Okay, sir.
Air fuel ratio.
Okay, sir.
Okay. But the process you mentioned very right, like how we can get that you know, stoichiometric air fuel ratio.
Yes, sir.
Pollutant also you answered very correctly. What are the different pollutants we can observe in petrol engine, diesel engine? तो वो ठीक था.
Okay, sir.
तो कार्बोरेटर में सबसे मेजर दिक्कत क्या आती है? कार्बोरेटर, you know, when there is a single carburetor, because obviously we cannot provide different carburetors for each and every cylinder.
Okay, sir.
तो क्या होता है, like suppose when you know we are having a carburetor kind of charge induction, तो
Yes,
क्या होता है, different cylinder they will not get equal charge.
exactly, sir. Yes, sir. I have read.
Okay,
Yes, sir.
maybe due to
Mhm.
their position.
Yes, sir.
One
Exactly, sir.
cylinder may be very close to the inlet valve, another may be far away
Far
from it.
away. Yes, sir.
उसकी वजह से क्या होता है, चार्ज वेरिएशन की वजह से क्या होता है, द वी विल ऑब्जर्व द डिफरेंट पावर. Okay,
Exactly.
different engine they will develop different power.
Yes, sir.
So
Yes, sir.
you know that is not good actually for the engine. So what we
Okay.
want so that there will be uniformity in the power generated by the
Exactly.
different engine cylinders.
Mhm.
And for that we want some very good control over the charge which is entering inside the IC engine, and that we get obviously by directly injecting the fuel into the IC engine. But yes, for that we need to provide very high pressure. Okay,
Yes, sir.
for that
Yes,
we
sir.
use common rail, okay, or maybe other different type of injection system.
Yes, sir.
तो वो पॉइंट आपने शायद कुछ मेंशन तो कर रहे थे आप, सिमिलर टू दैट,
Yes, sir.
but
But
this you can include. Pollution
yes,
was right, but ABS, I think you have not studied that, working of
yes, sir.
ABS.
Yes, sir. Yes, sir. मैंने भी पढ़ा नहीं है वो।
Unnecessarily इस तरह से फिर गैस नहीं करना है. ओके,
Okay,
हालांकि
sir.
यू मेंशन कि सर आई एम नॉट वेरी श्योर अबाउट दैट, अगर ऐसा लगे भी आपको तो वहां पे स्माइल नहीं करना है, आप बोलो
Oh,
थोड़ा सीरियस होके, कॉन्फिडेंट होके कि सर आई एम नॉट वेरी श्योर अबाउट दैट, बट
okay.
सम बेसिक थिंग आई फील आई कैन रिकॉल,
Okay, sir.
परमिट,
Oh,
है ना,
okay, sir.
ऐसा
Okay, sir.
बोलना है.
Okay.
वहां पे
Mm-hmm.
ये चाइल्डिश फिर वो नहीं दिखानी है कि सर मेरे को अच्छे से पता नहीं है ना, आपने बहुत क्वेश्चन अच्छे से आंसर किए हैं. ठीक
Okay,
है,
sir.
अगर कोई ऐसा
Mm-hmm.
क्वेश्चन फंस जाए कि दैट यू डोंट नो बट यू फील कि यू कैन गेस, तो
Mm-hmm.
टेक परमिशन फ्रॉम द इंटरव्यूअर,
Okay, sir.
बट वहां पे कॉन्फिडेंट रहना है. ठीक है, और फॉर्मली आपको लगना चाहिए, अनफॉर्मल बिहेवियर नहीं वहां पे करना है. ठीक है,
Okay, sir.
तो
Okay, sir.
मेरे ख्याल से बाकी आपका अंडरस्टैंडिंग अच्छा है नौशाद.
Yes, sir.
यू नो इफेक्टिवली यू हैव प्रिपेयर्ड दिस सब्जेक्ट. थोड़ा
Okay,
सा
sir.
वो देख के रखो, आप जो गाड़ी वगैरह चलाते हो ना, 3 सिलेंडर होते हैं अल्टो में, 4 नहीं होते.
Okay, sir.
हाँ, तो जो
Okay, sir.
गाड़ी आप चलाते हो आपने उसके बारे में पूछ सकता है वो कि वो सीसी कितना है, कितना टॉर्क आपको मिलता है, ठीक है, कितने
Yes, sir.
सिलेंडर है, तो वो
Yes, sir.
मिस्टेक नहीं करनी है उसमें. ठीक है,
Okay, sir.
थोड़ा सा बेसिक इन्फॉर्मेशन आपको उसके बारे में रखना चाहिए. ठीक
Okay,
है
sir.
निशा,
Okay,
ओके,
sir.
गुड लक, बेस्ट ऑफ लक फॉर योर फाइनल इंटरव्यू.
Thank you. Thank you very much, sir.